Okay, this is 2010 FRQ number 6 in a non-calculated function. Solutions to differential equation dy over dx equals xy cubed also satisfies this second derivative, that y equals f of x be a particular solution to a differential equation with f of 1 equals 2. So this is the initial condition. Write an equation for the tangent line to the graph of y equals f of x at x equals 1. So we want the tangent line. So clue, tangent means first derivative. Well, they already gave you that. So first derivative gives us the slope. So slope equals dy over dx equals xy cubed. Let's plug in x. X is 1. Y is 2. So that's 8. And we know that our point is 1 comma 2. So we can use point slope formula and write y minus 2 equals 8 times x minus 1. Right? You should clean this up because we're going to use this in part B. So y minus 2 equals 8x minus 8. Y equals 8x minus 6. That's my tangent line. Okay? So part B says use this tangent line to approximate f of 1.1, means plug in 1.1. So f of 1.1 equals 8 times 1.1 minus 6. That's 8.8 minus 6. That's 2.8. So about 2.8. Given that f of x is greater than 0 between these, the interval 1 and 1.1, is the approximation greater or less than f of 1.1? So is my tangent line approximation greater or less than? So then we got to check our second derivative, because as long as we know the concavity, we will know if it's an overestimate or an underestimate. If the graph concaves up, your tangent line is always going to be up below. It's going to be below the graph, so you're going to be underestimate. If my graph concaves down, my tangent line is always going to be above the function, so it's always going to be an overestimate. So as long as you know the concavity, you can tell are you an over or underestimate. So go ahead and plug in the point 1, 2 into our second derivative, and we can see which way it concaves. So second derivative, y cubed, y is 2 cubed, 1 plus 3 times 1 squared, 2 squared. That gives me, well, you don't have to work it all out because you can tell this is going to be greater than 0, which means it concaves up. So if it concaves up, all my tangent line is going to be an underestimate. So that means my answer, 2.8, is less than the actual value of f of 1.1. Okay? And then last part here says find the particular solution with initial condition 1, 0. This is the separable differential equation. So it says the initial condition is 1, 2. Here's your dy over dx equals xy cubed. All right, so first key word is separable. So you need to separate the variables, right? Multiply the dx over, divide the y cubed over. So dy over y cubed equals x dx. I would recommend to rewrite this so it's a little bit easier to work with. Y to negative 3 dy equals x dx. Take the integral, right? So the antiderivative of y cubed is y to negative 2 divided by negative 2. And then x is x squared over 2 plus c. At this point right here, well, you want to plug in your initial value. But I would recommend to just clean this up a little bit because it's a little bit harder personally for me to see the negative 2 as a fraction. So if I rewrite this as negative 1 over 2y squared, x squared over 2 plus c, I think it's a little bit easier to plug in the values. Okay, plug in 2 for y, 1 for x, so you get negative 1 over 2 squared equals 1 squared over 2 plus c. That gives me negative 1/8 equals 1/2 plus c. Move the 1/2 over, so subtract 1/2, which is subtract 4/8. So I get 5/8 equals c. That's your c value. So plug it back in here. I think that one's easier to do. So you have negative 1 over 2y squared equals x squared over 2 minus 5 over 8. Okay. Clean this up, make it into one fraction, because then you can flip both of them over and get this to be above. So you get negative 1 over 2y squared. And this, if you multiply by 4, you get 4x squared minus 5 all over 8. All right, so flip it over. You get negative 2y squared equals 8 over 4x squared minus 5. If you divide both sides by a negative 1, you get rid of this and you just switch these two over. So you get 2y squared equals 8 over 5 minus 4x squared. See how nicely that cleans up so you don't have to have so many negatives. All right, divided by 2, so 8 divided by 2, so y squared equals 4 over 5 minus 4x squared, and y equals plus or minus root 4 over 5 minus 4x squared. Now, you should only have one answer. You don't have two answers, right? So which one is my answer? Well, you use your initial condition one more time. You plug in the 1 and 2, see which one you get. So here's my check. I need 2 on this side equals plus or minus root 4 minus 5 minus 4 times 1 squared. Check the right-hand side. You get 4 over 5 minus 4 is 1. So plus or minus root 4. Plus or minus 2, well, I want 2, so that means I don't need a negative, which means then my real answer is just y equals root 4 minus 5 minus 4x squared. No plus or minus, just a positive half. Okay, that's it.